Hello everyone. We've had a few technical difficulties, but I think we're ready to start the event now. So yeah, I would like to introduce the Bogdan Godziadowski, who's the IRSE, former IRSE president as of only a few weeks ago. If you can come up and say a few words. Thanks, Bogdan.
This good like this, yeah?
Yes.
Okay, so
maybe
thank you, Ross. Maybe I'll move it a little bit closer.
Yeah.
Yes. Thank you, Ross. First of all, for invitation to come here, and I'm very happy to make it today here. In fact, my role is now immediate past president. This is the official form. And indeed, on the 22nd of April, I pass over to Rod Matam, who is our current president. And as you know, IRSE is a, let's say, organization with about 5,000 members, representing more than 50 countries. Yes, Denmark is a special place because you have the knowledge, you really deploy TCS, you deploy CBTC, and I am always wondering why there is no Danish section really yet. And I hope very much with this meeting we can really start and consider establishing Danish section for IRSE. And this is because the IRSE is about sharing knowledge and collecting knowledge. And also through licensing exams, learning more. Yeah, because in this discipline, in the signaling, we learn all the life. Okay, I am at the end of my professional career, but still there is a lot of learn, and I will never stop. And I think the same will apply very much to you. What else I would like to say is that yes, we are today in Copenhagen, but in various places I meet the same people. I mean, I work together with David on various projects, with Tilde on various projects. So this is where we try to share the expertise, really, what we learn elsewhere. And I think we have two main domains, if I can say so. So CBTC and ETCS, and for these two domains, we look forward, okay, and I was here 2017, I was making the review of the Danish system. I am pleased to be like after 8 years back in Copenhagen and to see that the ETCS deployment is progressing, CBTC is completed, and you think still about higher grades of automation, so this is all good. The only point is that your neighbors are somehow slower, and I think this good example of Denmark could be brought wider and for more colleagues around Denmark. So maybe, you know, if you start here with the IRSE Danish section, it maybe grow like more Scandinavia. I hope very much this. So today I understand there is a small program you prepared, Ross, with David and with Mirko, yes? And so we will go to it. I won't spend much time on further introductions, but I really hope that you guys, you can bring this IRSE section together and started cooperating much more international. I would kindly invite you to our Dutch section in the Netherlands. We started small, but today we have 180 people. And is also organizing events and meeting together, exchanging information. This is what IRSE is for, and hope that you will be successful in this kickoff and then just start really working together, which we do every day. But sometimes it's good to forget all the companies we are working with and just be together and like be a one community for signaling and telecommunication. So thank you very much, and I would like to pass now to David.
Thank you, Bogdan. So first of all, welcome to Nordic Signals. I'm quite excited to host the first in-person meeting for the EARS, and I really hope that we are going to have many in the way in the future. So today, so like Bogdan say, I think that the IRSE is really about sharing experience and also to touch on topics that are a little bit linked to innovation and not only about conventional signaling and how to design signal circuits, but maybe show some topics that are a bit innovative. So we at Nordic Signals, so we are, as our name says it, we are specialized in digital signaling. So we are a small company and working on large program in the US, but also in France and here also for the metro in Copenhagen. And one of our biggest project is in New York to try to help the MTA to accelerate their signal modernization. So today I wanted to share with you to give you a little bit about the history of the New York City subway, why they went to CBTC and how they have done it, which is quite unique because unlike Paris, in New York we have created our own TSIs. So we have specified and developed and implemented an interoperable CBTC solution. And also because we want to accelerate and most of all equipped all the work trains and all the rolling stock, we have to jump into some innovative solution to accelerate the fitment of the train. So this is what I will touch on in my presentation. So just a little bit about history. So some of you who travel to New York, it's a large system. There are 3.4 million passengers in 24 every day. There is a fleet of around 650 trains, thousands of kilometers of track. That's a huge network. The particularity of the New York subway is that there are two separate divisions with different characteristics for the trains. So we have the A division, which has a smaller rolling stock width, about 8 feet and 9 inch, and on the B division it's a little bit wider, up to 3 meters. So the New York City Transit has been built by consolidating several historic and legacy network into those one single network, but still two separate divisions with the same conventional legacy signaling system today, but separate operating patterns. So the train from the A division cannot operate on the B division and vice versa. It's also a system that is quite complex, and one particularity is that within one division, each rolling stock can operate on every single lines. And then we have also workshops connected to these lines that are servicing trains running on several lines. So it's an interconnected network. It's very different than in Paris, for instance, where each fleet is captive to each line. So it's not at all the same operating needs. And this adds some complexity when we are implementing CBTC, for instance. You will see later, when we are starting in the middle of this network, there are some operating requirements that we have to take into account, that you will switch from legacy to CBTC and back to legacy. We are creating temporary borders between legacy signaling and the CBTC for a long time. Then when we are doing another section later, we have to change again this border. It complicates also the implementation of CBTC. But why did New York go to CBTC? So in 91, there was a really bad accident at 14th Street that derailed a train because there was no continuous speed supervision. And the train driver was under the influence of drug and alcohol. So he oversped over a switch and killed several people. So from that, the MTA has decided to implement continuous speed supervision. So they have tweaked their legacy signaling system to add some more great time signal to control the speed. But there was a big decision to move to a continuous, to a modern train control system, and they decided to go directly to CBTC, but implemented as an overlay of the legacy signaling system, what we call the AWS. So the AWS is still there as a fallback system in case the CBTC fails, but with an extended headway. And one important decision that NYCT took at that time, because it's such a large network and trains can operate on any line within one division, they wanted to develop an interoperable solution. So first of all, they won't rely on only one supplier to do the carbon and the wayside, so they could have a pool of suppliers, and then they could have trains equipped with supplier A with their carbon solution, and the wayside equipped with supplier B. So a bit like ERTMS. So at that time, so I was working in New York at the end of the 90s, and we started to develop what we call the interoperability interface specification at system level and also at interface level between the subsystem, to be able to specify a system that could be provided by several suppliers. And also one thing that is important to note is that when NYCT decided to move to CBTC, they really skipped one generation of train control system, because they went from pure wayside fixed block system with trip stop, nothing in the car, so no cap signal, to CBTC. So this has been also a huge leap in technology, but also a huge leap in a way to operate a system, because they never went like many agencies in the US. They have still their track circuit-based speed code system. So they skipped this generation of technology. So this is just an example of the current legacy signal. So it's a wayside based on the train stop. So it's each signal control line is designed for the worst case. If a train pass a signal at red, then there is a train stop that will hit the emergency brake valve, and then stop the train within a certain braking distance that is calculated. So it's quite how could I say, rustic, conservative also. So when we put CBTC to replace this philosophy, it's also completely different in terms of operation. So interoperability. So this is just this is the first generation. So in my presentation, I will explain the latest development of the IRSE and the CBTC architecture, but really this shows that the current CBTC system, so the zone controller in yellow, are installed in every relay room. They are interfaced with either relay-based interlocking or SSI. And then we have a CBTC network with the radio, with the antenna on the along the track that communicates with the train, and the trains are also equipped with the carbon controller and the radio. This is a simplified view of this architecture. Of course, we have transponders on the track, but what is important to understand is that the CBTC system was really designed as an overlay of the conventional signaling system. And we have also an ATS, so a traffic management system, that is supplied by only one supplier for the entire B division, and that control all the routes through the interlocking, and as an interface to CBTC for all the CBTC function, like setting up a temporary speed restriction, work zone, and other restriction that the CBTC system has to enforce. So key CBTC function. So when a train is under CBTC mode, then the main function is to override the signaling. So that's why we are seeing here. This is a home signal before a switch. When the CBTC say, I have all the information, I know the state of the signaling, I know the state of the track ahead, I receive my MA, then the first function is to override all this control line within the conventional signaling system. And then it tells the train driver to look at his DMI and then to drive at speed, at the ATP speed, or we have also the ATO mode. We have some degraded mode in case we lose communication, for instance, with the wayside, with the radio to go in a restricted manual. In this case, there is the only supervision is the speed, which is done by the train. And there is also a mode, a degraded mode, where the train, in case it loses the communication, the radio communication can still run to the civil speed, because the track database is in the carbon. So even if it loses the communication on plain section of track, it has the civil speed profile. So it's a little bit better than the 10 miles per hour. And then there is the what we call the nuclear bomb, is the CBT bypass. When it's too difficult to switch to RM or AWP, then the train driver has a switch with a seal behind that he can break and run in bypass. Here there is no more protection, and it's even more dangerous because on CBTC lines we have removed a lot of signals, a lot of wayside signals. So there is much less protection, but sometimes when it's the rush hour and the train fails and you have a lot of train behind, sometimes the train operator are switching to bypass. And then we have the modes outside the CBTC line, which is wayside signal, and then yard mode, where we have a few supervision. So we supervise the switches, for instance. Okay, the new generation. So since 2022, we have tried to simplify the architecture of a CBTC, and we have moved to what we called. So we had three work streams. First of all, we wanted to get rid of this interface with the legacy signaling, because to validate this box here requires a lot of skills that only a few people in New York have. So for the conventional signaling, it's a special process. It's not the Senelec. It's a special process to validate each individual interlocking system. So we try to think, how could we simplify the architecture to get rid of this part of the system, because on every single CBTC project, this was what created all the delays, all this interface here, and how to validate the signaling principle into a relay-based interlocking. So what we have specified is a CBTC-centric. So we talked to the market. We knew that at least Thales and Siemens had what they call CBTC-centric solution, where their CBTC is already taking care of the signaling control function. It's part of the system. So with this architecture, we get rid of the complex interface with the AWS, and we validate one system, so the CBTC function and the interlocking control function. The second innovation was to switch from the legacy proprietary Wi-Fi radio supplied by Siemens to a real standard radio. So we moved to 5G. MTA bought a license to operate around 4.95 gigahertz. So they bought 20 meg to be able to have the CBTC radio operating into this space. And then we replace all the track circuit with axle counters. So here, these are all the reasons, but I think I already talked about that. This is the 5G. So also what was attractive for the 5G, but as we are progressing and designing the first line, we are a little bit, not disappointed, because we are very happy with this choice, but we thought that going to 5G, everyone says it's plug and play, 5G is standard, there is no link with the CBTC application. It's not true. You need to adapt your CBTC to work with the 5G, the way the 5G network is configured. For instance, if you decide to have only one path of communication between the carbon and the wayside, if you lose this path, the CBTC carbon needs to know when it triggers the switch to the other path. So there is a bit of coding to be done also at the application layer. It's not pure network configuration plug and play. But of course, it's much more resilient than Wi-Fi. It's highly available, and most of all, it's supported by standards. So there is no concern about obsolescence, at least for many years. So what is I2S? So it's a huge set of documentation. We have thousands of pages. So we have specification at system level that specify the functional requirements, the architecture, and then we have the interfaces for the carbon, the interfaces between the ATS and the CBTC, also between zone controller. But the most important, I would say, is these messages. What really triggers the interoperability is how you format all the messages exchanged between the wayside and the carbon. And this is really the core of the I2S. So this was the first generation. So this shows the interfaces specified in by the I2S. So there was the interface between the zone controller and the interlocking, between the radio and the carbon CBTC, between the antenna. So in green, it was the system supplied only by one supplier, Siemens, because we decided to go with their data communication system. So all the wayside DCS were supplied by Siemens, also for the carbon. So the interoperability with CBTC, for instance, the interoperability specification was for this interface between the carbon CBTC and the radio on board. With the CBTC centric, now we move the interoperability really at the air gap, because it's a 5G. So in red, you can see now the interface specified by the I2S. The current situation and ongoing project. So we can say now that it has been a success. We have started with 2 lines that were not I2S, because they are lines that are not with the captive fleet. So the IRSE line, which was made by Siemens, and the Flushing line, which is made by Thales. But these 2 lines served to build the I2S specification. So later on, we have upgraded the Culver line, the F, and then the Queens Boulevard West for the EFMR services. And this is the first real implementation of the interoperability. On these lines, we have train equipped either by Siemens or Hitachi now, and we have some zone controller delivered by Siemens and Hitachi, and we have also on an extension of Queens Boulevard on the east side, we have a third supplier, Mitsubishi, who is installing their zone controller. So we will have a line with 3 different zone controller, and with two types of carbon running on this line. So this is a success. We have also some line under construction. So we have Crosstown and Fulton, which go to CBTC centric with the 5G. We have 8th Avenue, which is 1 year away to be commissioned, and as I mentioned, QBL East, which is done by Mitsubishi. And we have just launched last week a tender for a new line in the CBTC centric for 6th and 63rd. All the trains on the Division B are equipped, more or less, except the work trains. We have an ATSB, so the traffic management system by Siemens, that is in service. And right now, one of our tasks is to assist the MTA to prepare the planning of all the rest of the B division. And we are also starting on the A division to have a more global strategy, since they are going to buy some new rolling stock. So we'll have to make new CBTC system contract and also to replace the legacy ATS. So this shows you the line that are in service. So the QBL EFMR is in service. Then the Queens Boulevard East is under testing. So is the 8th Avenue line in Manhattan, and then the Culver line in Brooklyn, which is in service also. And these are the lines that are either under construction or just the tender has been launched recently. So technology and innovation. So I talk about the CBTC centric. So with CBTC centric, so right now we are at this step 2, but eventually we want to go at step 3, where we are removing all the train stops and only keeping some signals to protect interlocking. Today we cannot go to this step 3 because we still have many work trains equipped. So these work trains still need some signals, some amount of signals, and train stop to enforce in case they run a red signal. So the plan is to equip those work trains with CBTC. However, we realize that one of the struggle is really is not so much the CBTC and the technology, it's really all this installation of peripheral equipment. So a tachometer mounted on the axle, balise antenna. It's a lot of engineering work, which you have to, you cannot duplicate it because you have many different services. I mean, we know that from the onboard project in BDK. So we try to optimize that. And there is another problem in New York is the transponders. They tend to disappear after maintenance work, track replacement. They are not yet used to that. Some of the guys who replace the ties, they see this small thing and they just throw it away. The consequence of that is huge, because the first train entering service into CBTC delocalize if you miss 2 balises, and it's a huge mess on the network. So yeah, here I have a picture of this transponder. So it's very small. It's not the Euro balise where you can see them in yellow. It's this transponder that were developed by Matra at that time, and Siemens that you can see on the Paris Metro also for their CBTC system. So it's quite small, and it tends to it's also a huge constraint for the maintenance, because when they don't disappear, they tend to put them not exactly in the same location, even though we have some tolerances. They are quite tight, so it also poses a huge problem on the operation when they put back the balises in the wrong location. And then as I was explaining, all this engineering to find the space for the antenna to pick up the signal of the balises, the wheel sensor, we thought that it was going to be a nightmare if we have to retrofit all these work trains. So for 2-3 years, we have had a lot of dialogue with the market, with CBTC vendors, but non-CBTC companies as well, who have worked also for the automobile industry and other industry, to try to see if there was on the market some technology for positioning that do not rely on the balise, the speed sensor, but more using different type of sensors, for instance, and if possible, with no installation on the west side. So we came up with some conclusion, so that this technology exists today on the market. It's not yet proved because there is no application today with train positioning not relying on balises in the CBTC universe. It doesn't exist. So what we are doing right now is that we have pre-qualified 2 suppliers who have different technology, who have demonstrated, so they have done some demo. One is an Australian company. They have fitted some freight locomotive and they have demonstrated something. The other one is based in the US, in San Francisco, and they have installed their system for other application on some abstract work trains. But we are convinced that the technology is here. We need to do a proof of concept and to see how we can adapt the I2S for this with this technology. So one of the solution is provided by a company called Piper, and they have a LiDAR solution. So they have two sensors mounted. So this is very small. It's like a small box like this that you mount on the top of the train here, and then it has two vital computer with software written in a different way, but that have to agree on the position, and the position is calculated by first of all, the system has to scan a line and build a database of fingerprints. So the first step is to build this track database of the infrastructure with a cloud of fingerprints, and they guarantee that there is no two fingerprints exactly the same. And their system is able, so once you do this database, which is stored in the carbon computer, so there is also a topic about the power of these processors. When the train runs on the line, the LiDAR are able to recognize which fingerprints and to translate that into a localization, like a CBTC localization as it is done today. So within a segment, they can say, okay, here, this point of switch is at this location with an offset compared to the segment. So we are going to equip one test train with this technology. This test train is equipped with the CBTC, carbon CBTC with the Siemens. And what we are doing is that we are going to compare the localization information calculated by the CBTC, and offline, because we cannot do it live, offline we are going to compare what the Piper solution has calculated. And so that's one test. The other test is with CBTC, one drawback also is if you delocalize, it's quite a heavy process to relocalize. So first of all, you have to run, first of all, you have to switch to RM. This is a complicated process because since it's a dangerous mode, we have to ask permission to the control center. It takes several minutes, and then we have to run over 2 balises. Worst case can be 1.2 kilometers. So the process to re-enter into CBTC with a conventional positioning is quite complex and heavy. Here, these guys told us, so this is what we need to demonstrate, that they can do a cold restart. So if you shut down their system and they are restarting to scan all these fingerprints, that they can do this below a minute. So this is what we are also going to demonstrate, to do a test live, to see how far it takes to do a cold restart and to relocalize safely again into the CBTC track database. This is the other solution. So it's quite similar, except that the technology of the sensor is different, and they are using a little bit of AI. So it's not the real AI like us, where it's unlimited content. Here it's first, they have the same principle. They are scanning the line to build a database of pictures and points. And then the software of the system, using AI and machine learning, is able to localize the train into this database that they have built. They also pretend that they can do other function because some of the sensors are cameras also, so they can also recognize signal aspect. So they could, in a theory, also link it to the signaling or to the CBTC to stop a train if your CBTC is not available for whatever reason. So this is the second supplier. So it's called 4AI, which is a company. It's a subsidiary of Fortel, which is an Australian company, and we are going also to test their system into a test train equipped with a carbon CBTC from Siemens, and we are going to do the same comparison as with Piper. This gives you some. So here, in terms of sensor, it's a little bit heavier because they have much more sensors. Like Piper, they have an onboard computing system, but which is quite small. It's usually one rack, And for the test, they are going to use some GPS, but it's not in the final production of the system. It's just to help them during the test. Yes. So in conclusion, we still have a lot of work to do in New York. Today, it's only 30% of the network is modernized with the CBTC. As I explained, all this simplification of the system, the 5G, all this evolution, we hope will make the implementation faster. So that's the goal, at least. I didn't talk about the change management. I think this will be another topic maybe, but there was a huge topic. Of course, it's not only about the technology, but the way they operate, maintain is completely new. So even though they have done IRSE 20 years ago, they still rely heavily on the CBTC suppliers to do troubleshooting, maintenance. So they are not yet there. And Bogdan knows that because he has worked with them also to try to help them to change their organization. And yes, and we can say that the innovation on the train positioning function becomes a reality. I think we are really convinced that we can demonstrate that. If we succeed, it will be a huge gain to not rely on the transponder and this heavy engineering of retrofitting trains with the antennas and the speed sensor, etc. So the next step is to focus on that. Once we have prove the concept, we will select one of the two companies, either Piper or 4AI, and we are going to equip first all the work trains. And then when we are buying the new trains for the A division, when we have matured this technology using the work trains, then we are going to rolling out also for the passenger fleets on the A division. Okay, I hope I was not too long.
That's pretty good.
Thank you for your attention, and please, if you have any question, I'd be happy to answer.
For the purpose of the people online, there's a microphone there if you've got a question. Can anybody check on Vimeo online to see if there's a chat working? I've been trying here and failed.
What about the ultra-wideband? Is this forgotten now, or?
So ultra-wideband. So we did the demonstration also with the Piper many years ago. So it's also a way to position the train. The drawback is that ultra-wideband rely on installing antenna and power supply on the along the way. However, what is attractive with Piper is that their vital platform for ultra-wideband has been certified by an independent safety assessor to Senelec, and they are reusing this platform for this application now. So right now it's parked, but in the back of our hand, if this is proved to be completely, too difficult, this could be our backup plan to go back to ultra wideband, because at least we have Piper and Humatics, another American supplier, who has demonstrated their products for the ultra wideband. Yeah.
If you just grab the mic and hand it around. I find the New York Metro very fascinating. Well, it's a very complex system, as you explained. From a rail capacity perspective, I'm curious to ask you if in this process of updating and optimizing the signaling, you also make real sort of operation simulations, and I'm thinking about what we use in Rumble, specifically software like OpenTrack and RailSys, which are really, of course, useful for a simulation of capacity, but they have also a very big signaling component, because without the signals there would be no simulations of anything else. So the question is this: do you
also use this software or something similar to, especially to help you in this process?
Yeah, so they have a tool that they are using internally, so to study the rail capacity, especially because there is continuously work on in the subway, so they are often having a possession where they are using work trains. So it's also important to resimulate the capacity when they are doing work on the track. So they are using this tool mainly for this. They have done some simulation also with CBTC to see the potential improvements if they have more trains, that they can run more trains. But the main, we could discuss about the rail capacity and the traffic optimization, but the main benefit I would say is, okay, CBTC gives you more because it's virtual block, moving block, but it's mainly with the ATS, with the traffic management system. In the ATS, so first of all, they do ATO, but you have an automatic train regulation function, which for some reason is not deployed because they have the way they build the timetable is not very accurate. It's done still manually, even though they bought, I think, Hastus or whatever tool, I can't remember. So they have the tool that could generate the timetable, etc. But for some reason, they don't use it. So potentially, this is where they could really improve the traffic is by activating this function which exists into the ATS. It has been tested. It's working with the CBTC, but they are not doing it right now.
Maybe it can be useful for you as well to see some solution that you put forward is more or less efficient based on how the trains have to be run in a certain line. Or so that was my thought.
Yeah.
So maybe I will say a few extra words.
There's a question from Antonio. Yeah.
So just take it out.
It's fine. I just pretty much I'm very curious about the equipment of the service vehicles and the solution they have found. And I don't know, maybe it's too specific, but what about the consist? Because I understand the tracking, which is very important, but I can see that here you have different compositions of train. Do they solve?
Yeah, so we know that this is the problem that they will have to solve. We are starting internally to, because we don't want to be too prescriptive in our specification. But of course, you cannot avoid to think about it upfront, so we don't go into every direction. So for the consist, we have started to think about several solutions. The worst case is we take the worst case and then we hard code into the system. And even if you have the most optimal cases, but then you will be penalized. This we need to discuss with the stakeholders if this is acceptable. The other option is to specify a way to validate a consist. Is there a safe way, because we need to take the safety also into account? Is it possible to do like with the ETCS, you validate consists or something like that? So we are looking into this other solution, and we will specify. I think we will more specify things that we don't want, like if it's too complicated to confirm a consist, and we know that our train operator will not be able to do it, then we will more impose constraints than prescribing a solution. But this is definitely this, and also the second topic to resolve today, they can also push consists. So the way they do, so they have the loco here, and the way they do the signal protection is that they have a guy sitting in front of the flat wagon with a portable train stop. So if you see that the signal is red, ping, he just hit the train stop. Very simple, but not. I mean, a bit conservative in terms of calculation of the braking distance. But this we will have also to think about this scenario.
Okay, before I add something on New York, maybe you can say something about migration strategy. How many trains in the Division B are now equipped?
So today in the Division B, so we have all the R160, all the R179, so it's about 500-ish something. Yeah. So there is still some R211, which is the youngest fleet, to be equipped, and then we have to buy a few extra to Kawasaki. But we are almost there. So there is no topic when we do a wayside contract. Normally we have all the trains equipped. It's more a way to make sure that the ones that are not equipped are not going to run on the CBTC line, because there is not enough signals.
So the let's say CBTC centric has really impact track side, not really on board.
Yes, correct. The carbon software IRSE function don't change. It's really an impact on the wayside, and it's an impact on the degraded mode, because before, one advantage to have a separate interlocking is that if you lose your zone controller, the interlocking can still light the signals. So you still have the aspect of the signal based on the fixed block. Here, since the interlocking is inside the zone controller, you lose everything. All your signals are dark. So in terms of degraded mode, it's a little bit more constrained for the operator. So when we started to specify that, it was not well received by the operator, but now we have convinced them that it's much simpler, much easier to implement. But the cutover, yes, I mean, the migration, we haven't done yet a migration of legacy interlocking to CBTC centric. The first one will be done by Hitachi on Crosstown soon. But this is always the critical activity, is how to cut over, how to go from legacy to a CBTC.
And maybe important stuff is to add, let's say, that the history of CBTC in New York is a bit okay, because there was like 1997 study, so it's like 30 years ago, which implemented the idea really what to do about legacy signaling and how to change it to modern system. And in let's say in conclusion of that study, it was really to go directly to CBTC centric, if you like, and not through legacy system. However, the practical implementation was different. And the two first line, CANRC and flashing lines, were really like a mix, completely mix. Okay, and they are also with the old radio communication systems. Also, this will be needed to be upgraded. I think it's because of the networking, how it is arranged, it is huge organizational issue. So we also did some studies on, let's say, how the organization should change, because it will impact not only, let's say, the way how they operate, but also the way how they are organized. Imagine that they have like maintenance teams dealing with the legacy system. They will have to learn new technologies and how to maintain them. Okay, and with free suppliers, it's not easy. So it's much larger scope than what David mentioned about, let's say, the innovations or the way how now the CBTC centric is going to be implemented. It's much significant extent of what New York is, what kind of challenge do they have. Also about ATS, you mentioned the Siemens one, but also there will be like, indication, okay, if they will accommodate within one ATS all the other lines, okay, because you mentioned 30%, but I suppose 30% is ATS-B only part. Not
no, the 30% are for the line, for the wayside. So we have only 30% in the B division, lines converted to CBTC.
Because ATS-A is still like completely legacy,
ATS-A, all the A division is a completely legacy. We have just started with the B division. So the ATS is both controlling the conventional lines with no CBTC, so the conventional interlocking, and the CBTC lines. So as we expand, the ATS-B also expands.
And the innovations regarding the, let's say, train positioning or train detection, also this will be another migration strategy, obviously. So exactly. So you see one place, one city, with huge network, with the complexity as David mentioned, but also you have to think about like the timing and let's see what is in scope and how to implement new innovations. We have the same story about the European train control system, where every innovation means like a change, and how to migrate is a challenge. Okay, thank you.
Except it's much easier to approve changes at the MTA than with
Of
IRA,
course,
I can tell you.
Okay, thank you.
Okay, thank you. Yeah, sure.
Is there use of these specifications, because you have quite elaborate set, by any other transport authorities, or are they somehow connected together? Is there some kind of overarching organization that's looking at this?
Yeah, that's a very good question, because we have tried with our clients. We went to talk to the Washington Metro. We talk also with BART in San Francisco, because they also Washington is about to start their CBTC program, for instance. So we went to them and tried to convince them that because now there is a market and these suppliers, they have developed the CBTC only for New York, they cannot sell it elsewhere, that they should maybe, instead of paying other consultants to write new spec and have a new system, that, hey, we have the specification already, you could put that specs into your tender, and then you will have the same solution than we have in New York. Maybe you can simplify some of the operational principles and signaling principles, but that's something we are trying to do, because it's also in our interest in New York. I mean that the CBTC suppliers can also have enough work, because one of the biggest risks of this program is that if it is too slow, the CBTC suppliers, they have so much work everywhere, right? That they cannot really keep those people on the bench if the CBTC lines are too slow to be contracted. So that's why it was a risk mitigation that we 3 years ago with my clients we went to talk to all these transit agencies that have CBTC program in the pipe. So far, they are not. They say yes, interesting, but New York is complicated, and our system is very simple. So they haven't decided, but that's a very good point. Yes.
And there's no organization that's somehow bringing these together.
You are absolutely right. So the story is that with I2S spec, okay, we create like the spoken system in a sense. Okay, so any change will impact 3 suppliers only for New York. Yeah, so this is the challenge really.
Yeah. But to de-risk that, now we are also talking to a 4th one, which is one of the main one, who is very interested also to enter into this market. So at least we will have 4 maybe, in case one defaults. So. Yeah, thank you. Is that it?
Yeah, if there's no further questions, then it's time for a coffee and cake. And for the people online, we'll be back online with the next session on EULYNX by Mirko Blazic at 2:30 Danish time. Thank you. Okay, for those online, we'll start the next session with a presentation on EULYNX by Mirko Blazic, who's the technical lead at the EULYNX project.
Thank you, Ross. So welcome to the session about EULYNX. So I'll give you an introduction to EULYNX. We will address some of the key challenges in our signaling sector, and we look at the strategy behind EULYNX, so how the infrastructure managers use standardization to improve the sector. And let's start directly with the challenges. So why now? The problem statement. So our sector faces multiple challenges. We can start with the complexity and diversity, something we refer to as the technology zoo. So we know the historic developments led to different signaling principles, different operating rules, different technologies, vendor lock-in situations. So these systems, the complex systems, they are challenging to operate and increasingly expensive to maintain. Then we continue, lack of harmonization. So we see that multiple variants for similar or even identical functionality. This is really problem pressure on the supply industry as they have to maintain multiple variants of platforms for this type of, for this similar functionality, and it's really no longer sustainable to maintain that. Okay. Now we know the delay. Then we have the obsolescence issue. It's estimated that over 50% of installed base in Europe is past its life cycle, and this obsolescence spiral is negative. It means the renewal rates are simply too slow. We see demands for capacity, for reliability. We have to be able to deliver more with less money. Somehow, we have a feeling that digitalization, digital technologies are coming to the rescue. Everything will be solved with digitalization. It is promising lower costs, better efficiency, but digitalization also brings new challenges. We have an increasing life cycle mismatch, so we have the shortening of life cycles of digital systems, so all the core systems, the life cycle is getting very short. And on the other hand, we have the hard trackside assets, which have a long life cycle. So we have this difference to be managed. We see the increased exposure to cybersecurity risks, and we see proprietary data silos. So with digital systems, there is more and more data, and this data is locked away from infrastructure managers. What we also see with digitalization is that most projects were managed as bespoke projects, so without any clear sector strategy or sector approach. And more or less, this is adding to proprietary technologies which contribute to our technology zoo again. So we are back to the original problem. So EULYNX was created to address these challenges, focusing on strategy to introduce modular approach to railway signaling. The priority of EULYNX infrastructure managers has been to enable open and standardized signaling deployment. So if we make a very simplified analogy, we can think of the USB standard, but for railway signaling. Good, so what do we understand with the term EULYNX? So from organizational perspective, EULYNX is an initiative of railway infrastructure managers. So we are a consortium of 20 members, 18 European infrastructure managers, and Saudi Arabia Railways and Indian Railways from outside of Europe. We're set as a standing organization for continuous development and maintenance of the standards, and we are well integrated into Europe's rail system pillar, so we contribute a lot of specifications also to the Europe's rail program. From content perspective, EULYNX is a framework of open standards focused on interface specifications. What EULYNX is not a product, it's not a platform, it's not software. So EULYNX is first and foremost a set of specifications. Standardized interfaces enable a strategic pivot for the infrastructure managers. So we are able to move from monolithic to modular architecture, and we are moving from an older buyer model where the railways, where the vendor owns the architecture and railways are guests in this system, to a new architecture model where the railways define the architecture and the vendors deploy the components according to this standardized architecture and the standards that apply to it. From the infra manager perspective, this is an important change and is seen as the right to repair, the right to upgrade, the right to secure. Let's look now at the modular architecture as introduced by EULYNX. So what we see are standardized interfaces and interoperable components which provide for the interfacing between the interlocking and the supporting systems to the field elements and to the adjacent areas. So we see here a little simplified architecture picture. That's a commercial one, but we will look later also a little bit more in depth. This approach is only sustainable with high degree of harmonization. So we have to also move here from inventing new variants by the infra managers and uninvent some of the national variants and harmonize at least into some kind of configurable packages. EULYNX focuses on communication, so on how systems communicate. So using open protocols, but still sufficiently open to allow innovation by individual suppliers. We can think of EULYNX, so digital transformation with EULYNX transforms the signaling system into signaling Internet of Things. So by now it's clear we focus on interfaces. So here are the four main interface types. SCI, so this is the interface for real-time signaling data, so between the interlocking and all the other subsystems. SDI is a diagnostic interface, so for non-safety critical monitoring. SMI, the maintenance interface, so for management of configuration, software updates, but also maintenance functions such as remote reset. SSI, the security interface, so ensuring secure communication, and this interface is fully in line with EU rail system pillar specifications. What about EULYNX and ETCS? So some words on this. Does EULYNX work with ETCS? Well, ETCS standardizes the train control aspects, but doesn't define the architecture of the signaling system. So this is where EULYNX fills the gap by defining this modular architecture. So you see here schematically the purple lines which define how interlockings, field elements, or control systems communicate, interact with ETCS. So together, EULYNX and ETCS form a coherent signaling system. Why is this important? Because once we have this based on a standardized signaling architecture, then also ETCS can be integrated consistently across different lines, across different suppliers, or even generations of technology. So without creating new proprietary silos or new dependencies with suppliers on specific networks. Okay, now let's look a little bit at the specific strategic value proposition that EULYNX enables, and we'll look at the vendor lock-in, life cycle costs, scalability, and asset intelligence. Let's start with a common renewal problem. So one subsystem becomes obsolete in these Lego blocks, and we are facing a vendor and or generation lock-in. So if we want to replace this, the interfaces are proprietary, so that means that the replacement scope expands. We face development, certification of new interfaces, of these custom interfaces, or we're facing a complete renewal. By using standardized interfaces, we can break this lock-in. So with standardized interfaces, we are able to mix and match the vendors. We can see that an interlocking from supplier A can drive a point or light signal from supplier B. So changes and extensions can remain flexible, so also after original deployment in respect to the vendors. This brings, in the long term, also better pricing and continued competition, so also throughout the system lifecycle. And also important, the infra managers are no longer locked to the innovation speed of one vendor. because they have really now the landscape open to multiple vendors. Now this maybe sounds negative now for suppliers, right? We're breaking the vendor lock-in, but suppliers also do benefit from standardization. So on one hand, as I mentioned earlier, this enables that they streamline their portfolios so they can focus on one standardized solution. And also important, it enables that they reach markets beyond their traditional reach, right? Because now a supplier which was working only for, let's say, their local railway, if they implement the EULYNX standard, at the moment their market becomes the entire EULYNX community. So they have 20 infrastructure managers as a potential market. So, and we see these small suppliers like level crossings and so on, they are able to access a larger market now. Okay, now on life cycle costs. So the first thought, the first impact of standardization, lower prices, right? So streamlined solutions, increased competition on the market, so we're looking at lower prices. But in this iceberg example, we should also look at some of the topics that contribute to life cycle costs, so beyond just the delivery, initial delivery price. And we see here topics like integration to existing and future systems, limited upgradability, and with that higher maintenance efforts. We have locked data from the vendors, repeated approval efforts, so each bespoke project has its own specific approval effort, so this all contributes to the cost. And unutilized life cycle of components because of the monolithic design. So this highlights where we can also look for cost reductions due to interface standardization after the delivery. And we particularly stress this last point, so the unused life cycle of components. As we are moving away from monolithic systems, the standardized interfaces allow that we decouple the life cycles of different components. So EULYNX enables that we use each asset for the complete life cycle. So we have modular replacement. We replace only what's obsolete and not what is still valuable. And if we take an example, so we have an interlocking renewal because the interlocking is obsolete. This doesn't need to force the replacement of, let's say, still healthy trackside assets like points and signals. And we have to know that in the trackside assets, there is actually a lot of cost buried because that also brings connected costs for cabling, for civil works, and so on. So if we can preserve that to the full life cycle, that really contributes to the overall reduction of costs. Okay, moving to the next point. So I want to say some words now on enabling scalability and industrialization. So we know our ETCS deployments are very, very slow, not really moving far. We see the demand, we see the obsolescence, we see the capacity demand, so deployments must get faster, more cost effective. And an idea of being truly scalable is that we are able to shift from custom design on each project to a kind of industrialized approach, so kind of copy-paste, if you will, of the same design, of the same standards across multiple lines. This brings speed as we have design validated once, deployed everywhere, and this brings efficiency as engineers learn one standard and not multiple vendor dialects. And I don't mean with the vendor dialects only protocols, but it means also the whole process, right? The design phase, implementation, maintenance. So everything is multiplied if we're not based on standards. What we also want to enable with this industrialized approach is increased use of hardware off the shelf. So we want to tackle the known hardware obsolescence and delivery bottlenecks. And this kind of final outlook, what we are seeing now is that signaling data centers are also recognized as a future approach for fast scaling. So we would have data centers. We can take the Norway example, right? So you can have a national interlocking data center and then a very small footprint on each line where you just deploy object controllers for trackside assets and communication to the data center. Then enhanced diagnostics and maintenance increase the asset intelligence. So we want to see how can we get the most out of our assets, and with standardized interfaces, so the diagnostic interfaces in this case, we are able to collect real-time data from multiple assets on standardized interfaces in standard format, conforming to standard and open data models. Now, with this, we can collect a lot of data, and this now opens the door to various analytics. We see new tools, new algorithms showing on the market. Suppliers are somehow competing, how much they can analyze, how much they can foresee from all this data. And this now really opens the path to just condition-based maintenance, right? So not so much on reaction, but actually really preventive maintenance based on the status of our infrastructure. So together this should contribute to really reduction of maintenance costs, because we can really revise how we do maintenance. And then going in the other direction, so for mitigating issues on the devices themselves, we also see the ability with the remote maintenance, so fast deployments of upgrades, so configuration updates or software patches, or reaction to security, cyber threats. So we also have, let's say, this remote capability in now this signaling Internet of Things. So does the approach work? Do we see any take-up on EULYNX? So I will highlight here first 3 examples, which some of you probably know very well already, of, let's say, ETCS rollouts in combination with EULYNX. And I'll give an example here for Norway, Finland, and Switzerland. So Norway as a pioneer from EULYNX perspective, so they went very early with EULYNX for their nationwide ETCS program. They have selected to go with one supplier, but to prevent the vendor lock-in situation, they are using the EULYNX interfaces so that they are open in the future. Finland, so the Digirata, the ETCS program in Finland is also heavily relying on EULYNX. Here we see a much, let's say, more concrete use of the EULYNX modular architecture, because they also took this modularity to the procurement phase. So here the ETCS part, so interlocking RBC, has been procured separately. And then they have, for the trackside assets, they had a separate procurement, and the 2 contracts are connected through the standardized EULYNX interfaces. And then in Switzerland, so we also saw recently awarded a long-term framework contracts to 2 main suppliers. Again, they are ETCS with EULYNX, but what they have chosen is to add another lot, which is supplying only object controllers. So that means the main vendors of the first 2 frameworks also have to integrate the object controllers. What this also shows is that EULYNX with this modular architecture also enables flexible procurement strategies. So we really see now different angles how the infra managers are approaching migration and then procurements. And that really depends on their, let's say, situation, on the status of their network, on their capability of their resources, and so on. So some words on implementations, tenders. So infrastructure managers are really increasingly now gaining confidence and integrating EULYNX in the procurement strategies. So not too many applications are already in commercial operations. So that's mainly, we see this now in Norway and in Germany on, let's say, the German variant of EULYNX. But the amount of tenders really indicate the market is ready. We can see the uptake in the French network. So the Argos program is connecting with EULYNX to axle counters. We see EULYNX tenders in Austria. We have a pilot in Czech Republic. And we see tenders like on Rail Baltica, High Speed Rail Poland, framework in Sweden, the Target 190 program in the UK, and also the Saudi Arabia. So all their new procurements which are coming out are including EULYNX. So that's really showing the maturity, there, and yeah, also then that's giving a clear signal to the supply industry that this is the way to go. What we see is then also, I mentioned these new procurement strategies. Maybe I give another example here of let's say kind of unlocked capability for procurement. Rail Baltica had to first, of course, are constructing the civil works and the infrastructure part, and they have the high-speed turnouts. And we know on the high-speed turnouts, of course, you need to come also with all this point machines, this complex mechanism with multiple point machines to handle the high-speed points. So they did not want to separate that part from the turnout tender. But then they had a separate CCS tender, which came a couple years later. So how to integrate this? And they decided that the right way to do it is to use the EULYNX SCIP, so the point interface. And it means now that the supplier of the turnouts has to also integrate the object controllers and then provide an SCIP interface. And then now the CCS supplier, which will come, will then integrate this SCIP interface to the interlocking. So this is really a new example how you can approach the tender, because otherwise they would need either an adapter or they would need to have the CCS supplier now to equip separately the turnouts, and that's somehow more complicated. Good. Yeah, what is now to mention in this new kind of new approach with the modularity? There are also some new roles. So the important new role, which was never in the domain of the infra managers, is system integration. So this is really something also for you, the audience, to consider. That there will be demand for system integrators. So we think from the start, the main suppliers who are, let's say, providing interlockings will also play the system integrator role, but this should more and more shift towards the railway side, so the railways are much more open than to integrate systems themselves. Good. Yeah, something on industry readiness. So we are working very closely with industry. So we have joint working groups. They participate in our working groups, and all the specifications, especially what we produce together in Europe's rail system pillar, are also approved by UNISIG. So this has really changed the game from early days where industry was in opposition. It's good what you do, but we will put that on the side. So now this is really, we're working hand in hand, and this is really helped us to improve the quality and increase the speed. All the main suppliers are on board, and we see they're actively developing solutions towards now our latest baseline 4. What we also see, of course, as I mentioned already, the opportunity for smaller suppliers. They are now able, by extending their product with a EULYNX interface, they're able to access a broader market. We also see a lot of demand from outside of Europe, so also suppliers from outside of Europe are contacting us for support, for information, how to develop EULYNX. We see Korean companies, Japanese, and obviously a lot of interest in India, as Indian Railways also joined EULYNX. There's quite a big push from the Indian companies. We have now this tradition that at InnoTrans we are showing the so-called products of the shelf. So we literally have a shelf and products on it. So to show to the customers, the infra managers, the maturity, the growing maturity of the market. So 2 years ago, we had 19 products from, I think, 12 suppliers. So I expect the range this year will also grow. So yeah, if you're at InnoTrans, be sure to visit us on our stand. Yeah, so what do we do beyond just writing specifications? As specifications are now in a mature phase, we are shifting the focus to help bring the standard from theory to practice. And I'll highlight 4 main activities: deployment support, testing, academy, and digital catalog. And I'll start with this. It's quite a common question, right? Is it enough to just refer to EULYNX in a tender? Can we just add one sentence, the system shall integrate EULYNX? EULYNX is a framework of documents, so not that simple. It should be seen as a toolbox. You have multiple subsystems, multiple interfaces, as well configuration options, different parameters, and so on. So every infra manager has somehow a different starting situation, a different migration path, so they need to prepare. So it's not sufficient that you're adding, give us a EULYNX system, but it really needs to be prepared for that infra manager. And with that, we started a dedicated activity, a deployment cluster. So we have a team of experts who offer support to the infra managers. And we can highlight this into three, let's say, phases. So first, we have a kind of onboarding. So we're providing the training, the introduction to all the EULYNX specifications and so on to the infra managers. Then we have this analytical phase, which we call connecting national specifications. So the focus is to connect EULYNX to all the national aspects. So here we have to primarily develop the EULYNX-based target architecture for the infrastructure manager. Then we evaluate which subsystems belong there, which interfaces do they want to apply, which functional packages they select, and so on. So we end up with a kind of detailed specification for that. We try to focus all of the IMs to harmonize, right? So that we are not adding new and new variants, but that we bring them to one of the variants which is already in the standard. And we analyze the gaps, and hopefully the gaps can be addressed on the infrastructure manager side with some small adaptations. Otherwise, they become change requests towards EULYNX. The results of this work then go into tender preparation. So that's the key focus. We want to see the smooth adoption of EULYNX to all the national contexts. And typical outputs that you maybe will encounter in your work will be some technical reports or migration plans or tender templates, for example. So these are kind of outputs that will then become available through the infrastructure managers. The next topic, I like to use this fun photo. It's a topic about testing, yeah. So modular architecture relies on standardized interfaces, but we have to make sure that they are implemented correctly, because interpretations in the specs can lead to integration failures. So conformance testing ensures that all the systems properly meet in the middle. So what do we do in EULYNX about this? We describe the testing process in conformance test plan. So this gives the testing approach and the requirements for the labs. And there are in principle two ways suppliers can test their products. They can either use their own labs through their Senelec process, or they can go through independent third-party labs. But in both cases, they have to use the EULYNX test cases. So this is the only way to really ensure that we have consistency. The results are a lab test report. And yeah, we want the infra managers to apply this harmonized process to avoid duplication and inconsistency due to, let's say, different approaches, different methodologies. What it also means that when using this harmonized process, we can have cross-acceptance. So the EULYNX infra managers will accept the test results without requesting their separate tests. Our role in this conformance testing from EULYNX, so we are not seeking any formal certification or so on, so we are not really a certification body or something like that. We are providing the test plan and the test cases, so we have a database of test cases. And we've started conformance testing as a service, a kind of non-profit initiative in collaboration with Relasoft in Finland, so to kind of lower the market entry barrier for these EULYNX developments. We expect that all of the major labs that we know from ETCS are also starting to look at integrating EULYNX testing, so in some years also this activity will pick up and testing will be available also through those labs. Why do I stress the EULYNX test cases? So in the testing process, so on one hand we have transparency, right? These are open format, fully accessible to all the stakeholders, and they are mandatory to ensure comparable and repeatable results. So to avoid, let's say, different interpretations by suppliers when they prepare their own test cases. These test cases are also then the basis for this test once, accept everywhere cross acceptance. All the testing outputs are also available through our collaboration channels, and in addition there is a database which also has machine readable test case format, so that this can be directly integrated into testing platforms. By the way, the bridge from the earlier photo is fine. Actually, that was just one of the construction phases, as it turned out that the bridge had to be pushed out from 2 tunnels and then meet in the middle. So it was in a week or so that they were waiting for the final alignment, and it was an opportunity for those photos.
So it was a real case?
It's a real case. It's a bridge in Croatia, so near Split on the Adriatic coast. Okay, some words on EULYNX Academy. So this is a training initiative that we started, catered to different levels of expertise. We have a very short introduction module, so it's an online module, 1 to 2 hours. You can get all the kind of basics, terminology, how the documents are structured, and so on. We have a comprehensive EULYNX basic training, so that's a 2-day training. And then we have various deep dives on specific topics like security, diagnostics interfaces, and so on. So far, the Academy has been running now 2 years. We educated a little bit over 2,000 participants, so we're quite happy with the turnouts here. We have a busy schedule this year. What we can also consider, if there will be interest, we could also consider organizing an academy session in Denmark, if that is maybe of interest. That we can also see. So we're looking maybe at 20, 25 participants is like a sweet spot. And if, let's say, if a venue can be arranged, something like this here today, then we can also provide this, let's say, free of charge as a training for the community. So that's something, let's say, to consider looking ahead. Yeah, we're preparing also some new deep dive courses, and we're also working now on a more detailed online course for the global audience. So as we see a lot of interest from India, from Australia, and so on. So we will try to also make this more online presence for that. We can also make really custom specific training. So if any of your companies would require training, we can also do that directly for you. Then some words on our digital catalog. We called it Vendor Expo. As I mentioned, so we were showing at InnoTrans products off the shelf, so the products shown, but that was only temporary and then they were gone. So we wanted to create a kind of permanent digital format, and this is why we then started this kind of online digital catalog on our website. So it's basically an exhibition space for the vendors, so we're hosting it in a kind of non-commercial vendor neutral platform. And the products then can be featured online, but they will also be featured at industry events. So for example, also this kind of catalog will be like a McDonald's menu on our InnoTrans booth, and you can look at the products there. So this Vendor Expo, you can kind of think of it as a web shop, but you just can't buy anything. Good, so that's that. So with that, I'm through the introduction part, and I will just quickly show a couple more slides, but not to go too far.
I passed through.
All right, so we're still good. Yeah, so a little bit more in depth than, yeah, in terms of the system architecture. So we can globally look that the architecture is composed of 3 layers, as I think you're quite aware. So of course the command and control on the first layer, the core systems on the second layer with the interlocking logic and RBC, and the third layer where we see the trackside and the object controllers. What you also see here is a little bit the separation. So the blue parts are the ETCS, where we are not defining anything because that is already standardized. So we're really doing the other part of the signaling architecture. Now a little bit of translation of our circle marketing picture into real components, real systems. If we start in the middle of the circle, we are centered, of course, around the subsystem electronic interlocking, and we have the two supporting systems. One is the subsystem maintenance and data management, MDM. So this is a system for maintenance and diagnostic functions. And we see the security services platform, the SSP. So this is for security service functions. On the bottom part, we see the object controllers, so the interfacing to the field elements. And on the top, we see the what we call adjacent systems, so the systems which are outside of our system boundary, radio block center and centralized ETCS level 1 controller, so these use the SCI RBC interface. Then we have the SCI CC interface for connecting to traffic control system and track worker safety, and SCI ILS for interlocking communication. The bottom part, so this bottom row of the field elements, so this is really fully specified. So these are the object controllers which are fully specified and harmonized. So they have some optional packages, so they can be a little bit tweaked by the different infrastructure managers. But in principle, here we see that really one product should be able to fit really all 20 railways of EULYNX. What unfortunately is not the case is on the systems above. So these are much more complex systems that are heavily still based on national signaling principles. So here we are not able to specify, let's say, the interlocking principles or the RBC. So here there is much less harmonization. So here we really focus on standardizing the interfaces as such. But then we need this phase of connecting to national requirements, national specifications for these systems. To mark the requirements for the specific infra manager on those interfaces, we use a mechanism which we call the infrastructure manager code. So each requirement will have a tag which has the infrastructure manager code. So that builds together the subset of the interface for that specific infrastructure manager. These interfaces, so which are, let's say, not so harmonized yet, really make sense for the infra managers who don't have a strong national standard. We see some infra managers have already a long-term, let's say, traffic management interlocking interface or interlocking. So for them, there is no use case to now just switch to another protocol, right? So this really makes sense if there is no such interface in place or if there is no competition for such an interface, right? So if you're locked into one vendor, then it makes sense to go with this type of EULYNX interface. Now this is the system architecture in more detail, so I don't expect you to read all of this here, but I think the main message, you see the blue rectangle around, that is the EULYNX system boundary, so what we see as EULYNX, and then you have here all the subsystems and all the actors that are used in the specifications defined. And every blue line, so all of these blue lines, so SCI, SDI, SMI, and so on, so these are the interfaces defined by EULYNX. So for each purple line, did I say blue? So for each purple line, you will see a set of specifications by EULYNX. So I already mentioned, so we have the 4 types of interfaces. What is also good to know, EULYNX, so the SCI, so for this signaling process data, we apply the RASTA protocol. And RASTA, in the protocol stack, RASTA offers 3 functions. One is safety, retransmission, and redundancy. So this is why we chose the RASTA protocol in our event-driven system. What is also to be mentioned, so RASTA is now a German norm, and now there is an activity on the IEC level that this will become an IEC standard. So now a working group has been started, and I think the target is next year to integrate RASTA also to IEC. Shortly, something about the EULYNX development process, so how we started, how we do our systems engineering. We started with collecting the functional requirements from all the involved infra managers. Then we are starting to create a model on this, so we are working model-based, and we capture these identified functions as use cases and describe them with sequence diagrams. Then the next step is creating the state machine models for these use cases. And these state machine models are then executable, and then we can simulate, we can have a simulator on these executable state machines that we use then for verification and validation. And we see, let's say, our specification, if we look at the Senelec V, so on the top part of the requirements part, we have what we call the so-called mini V. So we have a small product which is actually our specification. And we can see that we also have in this mini V, we have the verification part, so that the state machines are actually conforming to the functional requirements of the IAMs. And then we have the validation by the IAMs themselves. Yeah, so what are the outputs of EULYNX? So what's concrete that you can get your hands on? So I mentioned the standardized reference architecture, and then specifications for all the subsystems and all the standardized interfaces. We are providing also network requirements and guidelines, security concept, security guideline. We are providing the simulators, so for validating the interface functionality. For the modeling community, we also have available the model-based system engineering and the modeling standard, so that describes how we do the modeling. We have the assurance justification report, so demonstrating the EULYNX approach. And as I mentioned already, the conformance test plan and test case catalog. In total, it's around 60 documents that are now in our documentation tree. All of these outputs are openly available, so you can go on our website and there's a little registration form, and then you can get access basically to our collaboration space and all of the specs. Yeah, good. So another small advertisement for the Academy. So if you want to learn more, I advise you to at least look at the introduction module. So that's the online module, and then follow for events that are coming near you. That would be it. Happy to take questions, comments.
I have a question. Thanks, Mirko, for this really interesting presentation. We talked primarily about railway application. Is there any feedback from CBTC application, or have you heard about any interest in that?
Yeah, what we do see interest from some transport authorities. The most interest was shown actually by Delhi Metro from India, because they are a kind of let's say blueprint, mother organization for all Indian metros, and they wanted to adopt EULYNX due to all the same problems as we have on main lines, so all the vendor lock-in situations. However, let's say our architecture, let's say only part of this architecture is directly applicable, right? So let's say the field levels, maybe interlocking, and so on, but then there are, let's say, some specific parts connected to that. The discussion was in the direction that they could also use ETCS and ATO over ETCS, so that would also be an idea, but then there would be, let's say, still some interfaces to be developed, and for that they would need kind of cooperation, because that's also a bit heavy to fund from just one authority. There were a couple of others that also showed a bit of interest, and this was also kind of my reason for the question earlier, if we are able to also collect some of, let's say, the community. Because in principle, when you look at, especially at the field elements, those interfaces should be exactly the same. There is no need that an axle counter on metros is communicating differently than on mainline.
Some comments? Mirko, thanks, because I think that it's a really important subject, the EULYNX. But there's a history behind, okay? So in 90s, when we started with specifying European train control system, we were thinking about interlockings because it was really non-interoperable system. Okay, so at that time we started a project with EULYNX on harmonizing interlocking functions, and this project failed because interlockings were, let's say, the core business for signaling, and before 90s, there were so many versions of interlockings, mechanical interlockings, relay interlockings, first electronic interlockings, and it was always a system which was like also for various reasons, like individual for a country. So this project failed. We tried to define the core functionalities, but we have so many extensions and exceptions that we said, give up, okay? And there was another project which is called Euro interlocking, and then followed by IRSE project on the European Commission level, which took a little bit different approaches, and ending up with EULYNX approach, okay? I think, however, that still there will be some challenges because like with ETCS, you will have also various baselines. You have already baseline 4. What about backwards compatibility of EULYNX? And also, I think practical implementation is good, like indeed for countries like India who will have like blueprint. But today we have like the slow process of ETCS because also of the variety of systems applied in various railways, and we can't change everything at once. So unless the interlocking side will be really harmonized in terms of functionalities and how the system is established, and also standardized object controllers, the applicability of EULYNX could be limited in a sense, because you will still have to adjust to like how many wires have the point controller, etc. Okay, so my question is, how do you see really the future of EULYNX in terms of backwards compatibility if you will have to apply new functions? Because EULYNX today, the spec is like reflecting what we have today on, let's say, on the systems, okay, but maybe in 5-10 years from now, the systems could be completely different. How do you think the EULYNX can keep up with usability because of those changes, technological changes?
Yeah, good points raised. I think the key message is for all of our sector is to continue with harmonization and to bring these interlocking principles together. And this is, let's say, the key activity in Europe's rail system pillar is to try first to get to operational harmonization, to single European set of operating rules. As you can imagine, it's a slow and painful process. So we have delays in the program because it's not an easy topic in that sense. Following that closely is the development of kind of the new generation of European interlocking. It's called ETPS, European Trackside Protection System. And this is looking a little bit more, not so much on block-based approach as we have today, but more to train-centric approach. So much closer to the ETCS philosophy. The idea is that we have single set of operating rules and then single specification for this new signaling system. What we do in EULYNX, so EULYNX is now already in Europe's rail system pillar, and we provide, let's say, the basis, kind of the boundary conditions, similarly as ETCS, right? So this new development will have to be conform to the EULYNX specifications. So the only, let's say, changes which we expect to make in the next evolution would be in reducing some of the options. So we're trying to reduce some of, we have at the moment 3 variants how you reset exo counters, right? We could probably harmonize the whole Europe into 1 variant. And this is a type of example where we could still, let's say, simplify further. We looked also at topics like point machines, right? So we have different types of point machines. We investigated whether it makes sense to go for 1 standard, like the 4-wire. but in principle, it seems that from the infra managers, there is really no interest to go there, because there are, let's say, also so many constraints, and of course the installed base, so you can imagine this migration is not very smooth. But what we see on the other hand is for example, these new generations of object controllers, they're actually integrating everything. So let's say we saw the test of the Frauscher point object controller. It supports all types of point machines already straight out of the box. So I think that's one problem less to worry about. So that kind of makes the job a little bit easier. But yeah, the tough part is the harmonization. That's the tough part. So I think the specs, our goal is to try to keep them as stable as possible. We also see in ETCS the problem of too much evolution that the sector cannot keep up. So we have to stabilize. So baseline 4 should be stable for quite some time. And let's say baseline 5, our next baseline, will really be focused on this future view of the system pillar and connecting to that, so that to have a more streamlined variant. So that will be probably the two baselines that will continue.
Yeah, thanks, Mirko. I was at the IRSE convention last week, and in the DigiRail test lab in Kouvola, seeing an example of exactly what you described, where the Frauscher axle counters and Frauscher point object controllers, and then their local supplier MiPro was providing a general I/O and also the light signal object controller. The one thing that I noticed that was missing was level crossings, and there is a lot of ETCS railways that have level crossings. Do you know if there is anybody tackling that issue?
The specifications are out, so there is also, I mean, we in fact have two specifications for level crossings. So we have SCI LX and then SCI LC, just to make them the distinction. The LX is kind of the legacy, and if you saw the blue box of the system boundary, so LX is outside, and that means we only focus on the interface, because that interface is quite complex, depending where the logic is, all kind of combinations. What we want to focus on for the future, especially for ETCS railways, is the LC, and that's a subsystem, so object controller like point, which doesn't do any of the activation logic on its own. So all the activation logic is coming from the RBC interlocking, and the object controller is now, let's say, a stupid device which gets a command to activate. It activates whatever is connected on the level crossing protection facility, deactivates when it has to deactivate. So a couple of other things like, of course, the local operation and so on. But primarily we separate, now the logic goes to ETCS, and ETCS knows where the trains are, so we don't need the cabling, we don't need the striking points and things like that. No? So it's really a simplified landscape. More questions?
I have more like a generic question. This harmonization is probably happening in other industries, maybe automation. Have you any lessons learned from their way to automate, and how EULYNX is tackling?
I mean, we are primarily looking through the signaling perspective here, and not just so much signaling, because where the differences are really embedded are in the operations, right? So the ETCS operations have also, what has started on single set of specs has now deviated so many start of mission protocols and things like that. So this is let's say this is our first line of attack. So I don't think we can apply, let's say, harmonization from other industries in this sense, no? Because we really have to look first at our ETCS operations.
How about AI? Do you see any use of AI in the EULYNX? I mean, maybe it's a generic question, but I have seen once the EULYNX specification, they look very complicated. Have you seen any benefit, I don't know, from some infrastructure manager maybe to interpret and to link the specification through some AI models to make it more understandable also for the tendering phase? I mean, I know it's a bit generic question, but
concretely, no activities on this front yet. Of course, I would say not organizations, but some individuals have obviously played a little bit with trying to create these models by putting in specifications and so on. But there is, I think, for the moment, nothing yet. No, in the sense, what could be as a kind of interpretation or learning tool in that sense. But obviously, in terms of using something for real products and so on, is for the moment out of the question.
Are you using specific tools for state diagrams, or?
Yes, we're using PTC Modeler for that. So we're actually now, we will migrate because our tool chain is kind of end of life. So we will go to another tool, but it's basically SysML. So SysML models,
I've got a question on the design side of things, like the scheme plan, the signaling layout, etc., and the connection to the EULYNX data model, I think it's called. Because as we see in a lot of projects where signaling is part of a bigger project, maybe building a new line, so there's new track, new overhead structures, etc., all in a 3D BIM model or whatever, and there's Rail ML and other machine readable languages. Are there tools available to help signal designers to produce a signaling layout in CAD format or whatever?
Yeah, this was an activity early on. We had a data preparation activity, but which was unfortunately stopped because, I mean, we had quite extensive data models from several infrastructure managers, but they were quite complex because they had to cater, let's say, not only for EULYNX, but really also for, let's say, general legacy technologies, right? If they were to be kind of universally usable. What was the problem with that is that we saw that none of the suppliers would directly take that as an input. So they would, because their tool chain, which is the kind of certified tool chain which they have for the design, they are reluctant to change that. And because don't touch it. And that means they basically would translate whatever they get from this EULYNX model anyhow. So there was always, so it was a question, is it one translation, is it two translations? In the end, there was not, let's say, sufficient adoption, and we discontinued that. So you will still find on the website these data models. What we are doing now is, let's say, bringing this on the EUROPE's rail. So there's also a data model that's coming to life here that's connected closer to ERA ontology. So kind of this is the where we try to bring things together, and the colleagues in EUROPE's rail are looking at some of these, let's say, design elements for this. So, but that's in general not just EULYNX specific, but it will be for kind of all parts that are somehow in the system pillar. So that, I would say, it's now a kind of research phase at the moment. So the data model is coming out, is already published, and it's kind of slowly growing. But we're not there yet where you want to be with your question. Good. Any more questions? Okay.
Okay, thank you very much.
Thanks a lot.
I think we're 3 minutes over, so it's time now to focus, have another coffee, and focus in on the IRSE Denmark. And we're planning a session. I can see that there are 4 people online. So if you're not based in Northern Europe, then maybe we'll just say thank you very much for joining, and you're welcome to go off and do other things. But here in the room, and if you're prepared to stay online, there will be a online poll where we can get some feedback on how things have been going with the IRSE Danish section so far and ideas for the future. So yeah, you can let me just check the detailed time for the agenda. So we'll take a short break of 5 minutes or so, and then we'll start with a workshop. Thank you very much.
Right. So yeah, we can start the last bit of this day. Well, first of all, thanks Bogdan for the intro to open for the IRSE section in Denmark, and thanks also to Mirko and David for delivering such interesting topic, really fascinating topics. To continue with the IRSE section in Denmark, we would like to, we have two things for today for this small workshop. One is to gather ideas, and the other one is to get some hands. We need some help to really take off with the IRSE section in Denmark. Me and Ross, we have done some work at the beginning to organize the first online event, and then this event also with the help of Nordic Signals, sparing from you, Bogdan. But to continue to make something tangible and concrete, we need some help. But first, some ideas. So to get that started, we have prepared, I think you can see on the screen, 7 questions that we will go through one by one. You can, from online, you can join with a QR code.
Yeah, if you start the presentation,
and I think if we start with the first question, then there will be the QR code that you can scan also here, guys. So you can join the pool online.
if the technology doesn't work, there's paper.
There is also paper, yes, available. But that will be more for the members that we will pass around. Yeah, it should.
For the presentation to start.
How do you do that? Present. Okay. Thank you. So the first question is, how often should the IRSE decay old events? Yeah. Shut out your. Write your answer.
Feel free to share what your thoughts are.
The goal, I think, will be at least 3 to 4 events per year. That can be mixed, of course. The intention is not to have just conference like this, that, of course, super interesting and a lot of learning from such event like this, but there was also the idea to have some site visit. So there will be a mix of conference and visit quarterly, 2 to 4 times annually, yeah, 2 to 4 times, 3 times, yeah, that sounds all quite aligned with what, yeah, we had in mind. Okay.
There's still more coming in. I can't tell it. How do we know when everyone's responded?
Does it mean 5?
Yeah, what do the numbers mean?
5 responded, I guess. 4 connected.
But it's because you go offline.
Well, we got 5 answers, and I
Yeah,
think we got what we want from this first question.
Yeah, if I mean, we can also accept responses afterwards by email or whatever. We're not.
Yeah.
Yeah. This is just a chance to generate some feedback and ideas. Thanks.
Indeed. Question number 2. What time of the day and year will be best? 7 a.m. in the morning or 8 a.m. like the first one? I think was good time.
We got a lot of people.
On the first webinar, the early morning.
I think sorry, I'll just unmute myself. Yeah, I think the hard thing about what we did today was I know a few people were on holiday or having trouble getting away from work. So another idea is to do it a little bit later in the day,
Yeah.
more into the evening after work.
Yeah, in fact, I can see some proposed afternoon or evening, around 5 p.m.
What about time of the year? I mean, are we talking quarterly or do people prefer?
Like time of the year, like
Yeah.
every
Yeah,
Maybe
exactly.
quarterly,
That
yeah.
was not at Christmas.
not in Christmas, no, but one like in spring, like spring, summer, like
Yeah.
today, I think, and one in autumn. If we think about 2 sessions, for example, that could be something. But at least we got the time now, after lunch, afternoon, so nobody's fun for the early morning session as we
I
had.
didn't. No one said that.
No one said at 8 a.m. or 7 a.m. Yeah. All right, yeah.
I think January also is the longest, darkest days in Denmark.
Yeah,
January to June.
So it's better to be inside talking about signaling.
January, yeah. Beginning of the year. Yeah.
February is the worst.
January or February. Yeah.
February is very sad month.
It's a sad month.
Maybe you organize
January with all the good intention. Okay, I want to learn about signaling and be part of IRSE. And
It's very boring.
Yeah.
We will need a lot of lights.
Exactly.
good. Ross, this will be saved, right, in the pool, all these answers, so we can collect.
Yeah,
and,
it's also being recorded, so we
all
can
right,
see.
yeah, true. Okay. Question number 3. What topics would you suggest? Would you like to suggest for the future presentation? Go wild. Assessments. Interesting.
Suggested we want to hear or we want to do present?
Both.
Okay.
Can be both. If you have a topic you want to present, yeah, please. But it will be for, yeah, which topic would you like to hear, yeah, primarily?
Maybe at the end of this questionnaire, I can give you some ideas what we do in the Netherlands.
Yeah.
So as an example.
Mm-hmm. Okay.
Do we have one for about site visits?
I think we do have a question for site visits. Yeah. So ongoing projects, supplier products. Would you like to hear about metro solution with no secondary detection? So really, really native, specific. I wonder who has put that topic. Assessments, yeah, that's something that, well, yeah, I can also do some presentation about that. I know also our colleague from Alstom. We can also think about that. Why not? Yeah. Yeah. Signaling improvements in DK in Denmark and the Copenhagen Metro. Yeah. All relevant. Good. Maybe we can move for the next question. We have some bubbles that are waiting for us, so maybe we have to go through quickly now. Let's do it properly. That was about the site visit. So the question is, shall we organize visits? If so, what would you like to see? Site visit, like in a workshop, in metro workshop, or for example on trackside, on a line.
I mean, we could make it a theme day with some ongoing projects like the Fehmarn Belt, for example. They've laid their first tunnel section in the water recently, and there's a lot of stuff going on down there.
In Denmark, yes. Of course, it will be in Denmark.
Or just over the bridge.
Or over the bridge in Malmö, yeah. Why not? Control centers at Metro or BDK, yeah. They are not far from here. Bridge in New Cobing Falster. Yeah, that's very specific. But
could be to visit one of the supplier factories or whatever.
Yeah. Yeah. Alstom, they just inaugurated the. Yeah, but indeed, as you were saying, Ross, yes, one of the supplier factory. I know Alstom, they just opened a big office in Vildro. They might have some labs. I know that they have, Antonio, I know that they have a big lab that they have opened in Villero. So maybe it can be something to see at Alstom. Or the joint test lab, yeah. Okay. Next question. No. Oh, sorry, I was maybe too fast. There was something else. CTC, Öresund Bridge, track updates, yeah? Sure. Okay, good. It's a bit small here, the layout, but the question is, would you like to join the organizing committee? If so, please state what roles you will be interested in with your name and email. With that regards, for the audience here, we have also printed on paper, the same question also on paper, so you can leave your details on paper.
If you prefer to keep things private, then feel free to email us or that's.
And just to make it clear, this will not be a solo, organization committee, but it will be a group, eventually of 4 or 5 people. We'll see that will help to organize events like this. So, and we should have also some fun.
Yeah,
so it will not be a boring session where we brainstorm about. Yeah, we also have to do that, but we promise to keep it casual and fun.
Just in case you can't read it, we need help with the communication and publicizing the events.
Yeah.
We could do with help organizing the events. At some point, if we get big enough, we may have some money to take care of, etc. So, I imagine in between events, it's not going to be like we meet every week. It's probably just 2 or 3 times a year. I don't know.
Yeah, something
that maybe we can have Bogdan give a little bit about the workings in the Netherlands in a minute.
Yeah.
Once we finish our
I think we just have 2 more questions. So. Then please, we already have 2 have given their availability, so
excellent.
That's great. Question number 6, regarding the first online event and this second in-person event, what did you like, and would you? Okay, this.
What can be improved?
What can be improved? This was you, Ross. And what could be improved? And again, we can also have a session afterwards, maybe with some of the people that have already provided their names. But if you have any suggestion about the first event online and today, please bring them in. Maybe also you, Bogdan, you will have some feedback.
Yeah, I immediately want to improve access to the Vimeo stream,
The
so
technical
I
part.
can. It doesn't take me half the event to find out how to see if the stream's working.
Yeah.
Well, the first
But,
time is always there, you know. So
Yeah, I'm sure we lost some online viewers at the start that tried to join. So.
That happened also on the first.
Yeah.
Event. Yeah. Okay. Something to improve.
Yeah.
Yeah. Okay. About the second one. But the second one, the presentation topics both were great. Yeah. Nice to hear. Maybe if we can pick up the weather, maybe a rainy day could be easier to stay. No, this we cannot choose and we cannot improve. No.
what do you prefer?
Let's prefer. Sitting inside on a rainy day maybe will be better. No, I think it's nice. It has been a really nice location here also to so once again thanks to Nordic Signals to host us today. Okay, we can move on to the last question. Open. Anything else would you like to add? Not really. Good. So
Nothing about
I
venues. Where we didn't have a question about where. We had what and when, but no.
maybe it would be nice to have, if I can add like a venue to get some, can be at Metro Selskab next time or at Bane Denmark.
There's also EDA. I did at
Yeah.
Rails CPHO. I did touch base with the guys at the stand for EDA. There's the possibility to maybe share event information once we know a little bit more ahead of time. That's always been the problem so far, is settling the date in time. But if we get a decent plan, then we can also maybe get hosted
book,
there as well. It's
yeah.
a nice venue just down the
Yes,
harbour a bit.
not far away from here, indeed. Good. Bogdan, you had some feedback you want to share from the Dutch section?
I think you
Yes.
can probably lock the. I think lock the poll now.
Yeah.
Sonia,
Lock
there's
Yes.
and exit, and hopefully that
Can you-
will
can you
save the
go-
responses.
Can you go to another website maybe? Let's just leave it. Just
Like this,
I'll just put maybe.
the IRSE website. Or?
Yeah.
Oh, yeah, good idea.
Okay, I'll say a few words about the Netherlands, okay, because that's maybe a good reference, okay. So in the Netherlands we are like 15 years, let's say, busy with the IRSE section, and yes, the beginning was also not easy, like here, okay, few people, okay, but as Russo and Antonio said, okay, there's a need really like for 5-6 people who are active and proactive approaching others, because then it grows. And today we have really 180 people in the Netherlands. Okay, so it's really somehow largest, I think, third largest section within the IRSE. And what we do is various things, events, and the events are like 4 or 5 times a year. But we have pretty wide, also industrial based, so consultancies and industrial based, and also Dutch railways, like train operating company, and also freight companies, and also obviously ProRail, but also a lot of cities with networks like Rotterdam, Amsterdam, Utrecht. So we try to balance between like main lines and city networks, and let's say the presentations are mainly really concerning the Netherlands, are in Dutch, but sometimes in English. We have also invitees, so we invite also colleagues from other countries, and sometimes they are coming. Easygoing is Belgium because it's the same language, but also from other countries. Like now we have visit tomorrow from young rail professionals from UK. So young people, like 30, 40 people are coming, and we are like hosting them really and showing them what do we have in the Netherlands. Okay, so these are the ideas, I think. Also maybe for you to look wider, really. Yeah? So not only focusing maybe on the main lines on Banner Denmark, but trying to look what city networks are doing, because this is also interesting. So this is one stuff. What we do also is collecting the knowledge. Okay, so we have like a kind of knowledge database in the Netherlands, separately what UK is doing and what is on the general website, and you will see, you can read it likely. So like very much generic stuff, the basics, the life cycle, and also like starting points and the context, and then we go like inputs, processes and outputs, and we try to collect all the information from various colleagues we have, like about ERTMS, about legacy systems, and in this way, for younger colleagues, it's a very good like basics to learn from. Okay, so that's really what we try to do in the Netherlands, and I think you should also try to look wider. Maybe try to ask colleagues like from the Netherlands or from UK or I don't know, from other countries to come and present, because sometimes you may be stuck. Okay, what we should do next and so on, but maybe the explanation is to share the knowledge from other places. This will work very well, and this is what we try to do always. You should have also presidential visits, like my visit, but okay, Rod Matram or the others, okay, who like today is very much ad hoc, but normally when I was visiting other countries, I had my presentation. What do I think about like certain points and issues, okay, and yeah, I think context of Denmark is really like the one of the early deployers of ETCS and also CBTC is very interesting, but compare it to like the rest of the Europe, okay, so you are far really away, and you should look much more further, okay, and for the young people I think it's also like very special to look like for mentorship. Because what we try to do also in the Netherlands is like a mentorship. Okay, who within our network is the one who can help you to develop, and to grow? Because it's your individual career, it's your life, and how to find a good way towards the future. So sometimes it's good to listen to some mentors to see, let's say, how to decide really, or, based on experience from the older ones, okay? And also to develop vision, what you'd like to see in the future, like your vision, okay? Because what David is telling, what I am telling, what Ross is telling is nice, but it's our mind and our perspective. Your perspective could be completely different. Like Mirko, only at the end of the presentation started to tell about like future interlocking, okay? Such a stuff, okay? So try to think about it commonly. Yeah, so that's about what I would like to propose. And formally, Ross knows, and I think also too, that normally the rules of IRSE is about like 40 members should be to create a section, but I think we can easily escape having like 10, 15 much more active, should be enough, okay? Yeah, so that will be my advice, and please work with the current president closely, because this helps, and if necessary, like me today, Rod or future, let's say Youssef or Harv could come here and also have a presentations like about, let's say, what they do. Yeah. Rod has very interesting story about artificial intelligence applications, so he can like click and have a presentation for 1 hour about artificial intelligence in signaling. There will be others like Harv who can tell you, okay, what he's doing in transport for London. So just use it.
So the topics are there. There is
Yes.
people
Yes.
capable of delivering
Yes, it is.
super interesting topics, and we need people. We need people to join and to maybe, as you say, the good connection with the young generation, with the university. Try to get them involved. We were discussing before that maybe there is not really a railway engineering course at DTU. Now I'm not up to date, but I understood that there is not really a course in the railway engineering. Maybe we should try to talk with other courses like the transportation, but the goal is to attract also the young engineers, either from the school or already in the industry.
Yeah. But also what I try to do is like connect younger colleagues from various countries. Okay, so we have like young professionals in the Netherlands, in UK, in France, in Switzerland, and we try also to create a kind of opportunity for them to come together. Because this organization is for knowledge, but also for networking. And I think for your careers also what is very important really to know people, because then it's much easier to talk to.
Yeah. And in fact, I think this is the power, one of the powerful tricks, let me say, from IRSE, that you can have a really international network, because, let's be frank, there is also IDA Rail here, there are also Banebranchen, there are already some other railway organization in Denmark, like I'm sure also in Netherlands, but the difference of IRSE is that you can have an access to wider and to have a more global network, I would say.
Yeah.
So
it's
also
more focused on signaling in general as well, but not exclusively. And I'd just like to add that the IRSE has been a huge part of my career, starting in Australia and then moving over to Europe. And it was one of my managers in Australia who was a member of the IRSE who recommended that I join, and I think it's you get a lot of information as a regular magazine, and you can, as Bogdan says, there are always events going on in other sections nearby. Which also include online events as well. So there's a lot of information out there that you can get access to. So
but I think also, let's say that you create it, nobody else. Okay, so it is really up to you to think. Okay, is it useful for you? Okay, in the old times it was like Ross said. Okay, the boss who said just be a member of IRSE. Today we have different times. It is you to see like benefit of joining the organization. So but you create it also. Okay, so it's both ways. So that's it.
Okay. Thanks, Bogdan, for sharing your knowledge. I think what's next. Of course, we'll collect the information and the feedback that we have in the pool, but also from the talk that we had today. And I think we will also reach out to the members or to the people that have volunteered to be on the mail list. And so I guess you will hear from us in 2 to 3 weeks' time, something like this. You want to add anything else, Ross? Or we can go for champagne?
Yeah, exactly. Unfortunately, there's 3 people online who can't join us for refreshments, but we have a balcony in the building here where Nordic Signals are kindly offering us to socialise there for a bit. There is also a table booked up the road at a restaurant, so if anybody is keen to stay on and have a meal, you're welcome to join. We've got a table for 8 people, so just let me know. And I think we'll bring the
to a close,
event to a close. Yes. Thanks very much for everyone that came along and made it a good event.
Yeah.
And thanks David, Nordic Signals, for a great venue.
Yeah, you're welcome. And you are also invited. We have some bubbles on our terrace close to our office.
Yeah, we look forward to that.